Hello everyone, I am Dr. Manzoor Ahmed, Assistant Professor in Mathematics, Marri Laxman Reddy Institute of Technology and Management. Today, we are starting a new lecture series on Fundamentals and Applications of Vedic Mathematics. That is a new subject introduced as per Indian knowledge system, and we are starting the unit third of the subject, which is in our curriculum from this year only. The other two units have already been started by other faculty members. And today we are starting unit third, that is lightning squares and rapid cubes. Before starting the lecture, we will have a look at the contents of the unit, that is understanding easy square roots, implementing easy square roots, that how to implement them. And then we have some sutras as per Vedic mathematics, that is Ekadikena Purvena Sutra, Dvandva Yoga, Bodhanya Shalbus Satra, and Yavadunam Sutra. These are four sutras, and we are using those sutras to solve squares or to find the squares of numbers and cube roots of numbers. That makes cube roots and square roots easy using Vedic mathematical techniques. Let's start with the introduction first. Vedic mathematics is a very ancient technique introduced first by Shri Bharti Krishna Tirthaji Maharaj in 19th century. The purpose was to solve mathematical problems easily and very fast. Though it is a very useful technique, but it is not as much popular as modern mathematical techniques. So as far as Vedic mathematics is concerned, there are 16 sutras, which is also known as formulae, and 13 sub-sutras, based on which we solve problems very fast and very efficiently. Vedic mathematics derived its name from the Vedas. Why it is called as Vedic mathematics? Because this mathematics has mainly been derived from Vedas, particularly the Atharva Veda, which is the fourth Veda. So it deals with branches like engineering, mathematics, sculpture, medicine, and all other sciences. Vedic mathematics has its applications to arithmetical computations, theory of numbers, compound multiplications, algebraic operations, factorizations, simple quadratic and higher order equations, simultaneous quadratic equations, partial fractions, so on and so forth. This was about the introduction of mathematics, which other faculty members have already started in Unit 1 and Unit 2. So we will straight come to the first topic or the first sutra of this lecture, which is Yavadunam Taraduni Kritya Vargena Yojayat. So again I am saying Yavadunam Taraduni Kritya Vargena Yojayat is the first sutra in Vedic mathematics to find the squares and cube roots of numbers. In Vedic mathematics, we should first understand, or students should first understand, that the base is always given in the form of 10 raised to power n. So the bases are like 10 or 10 square or 10 cube or 10 4 and so on and so forth. So the first base is 10 to the power 1 or 10 square, 10 cube and so on. So when we use this sutra, we have to find the extent or deficiency of a number to be squared with respect to its base, and then this extent or deficiency is termed here as the deviation. So first, when you are finding the square of any number, we should first know that how much the number is deviated from its base. And students should remember that the base is always taken to be the power of 10. So the bases are, once again I am saying that the bases are either 10 or 10 square, that is 100, 10 cube, that is 1000, and 10 to the power 4, which is 10,000, so on and so forth. So for example, if we have to find the square of the number 12, so this number lies close to the base 10. So firstly, we have to find the extent of deficiency. That is, 12 is 2 units or 2 places greater than 10. So that means the deviation here is 2. So in the next part, we set up the square of the deviation at the end. So we will go through some examples later. But first understand that when we have to find the square of any number, first we take the base, which is in terms of powers of 10. And second thing, we take the deficiency of the number, which is how much units it is increasing or decreasing from the given base. So in this example, as we have taken the example of 12, 12 is 2 units more than the base 10. So the base in case is 10 and 12 is 2 units, or we can say the deviation is 2. Then I have given in the note as well, in Vedic mathematics, base is always taken in the powers of 10, that is 10 square, 10 cube, 10 raised to power 3 and 10 raised to power 4. These are the bases in Vedic mathematics, and students should always remember that whenever we are dealing with the problems of Vedic mathematics, we should always remember with this base. So this sutra YTKVY, which is Yavadunam Taraduni Kriti Vargena Yojayat, works better when the numbers to be squared lie near to the base 10, 100, 1000, 10,000. And in second case, if it is a multiple of the base, that is 20, 30, 40, 50, 200 or 300. But in this lecture, we are starting with the first case, when the number is near the base 10 to the power n, or which is 10, 100, 1000, 10,000 and 10 to the power n. The answer to these types of problems for those numbers which lie close to the base 10 power n, the answer is arrived in two parts. LHS of the separator equals to number plus deviation. I have already told you about the deviation, and deviation may be positive, it may be greater than the base, or it may be lower than the base. So deviation may either be positive or it may be negative. So RHS of the separator, which is the square of the deviation. We will go through some of the examples to understand this case properly. So the RHS part of the separator will contain the same number of digits. Here the students should remember that when we take the RHS part of the separator, the student should remember that the digits to the right of the separator should be equal to the number of the zeros containing the base. So if the base is 10, the right hand side of the number should contain only one digit. If the base is 100, the right hand side RHS part of the separator should contain 2 digits. If it is 3, we have to add one of the digits to the left side. So when we go through the examples, we will understand it particularly or specifically. Here is the first example, or we have to find the square of 12. So first, as in the previous case 1, we have already discussed about these things. Now we will try to implement these things in our first example, which is to find the square of number 12. So number 12, as we know, it lies close to the base 10. So first, students should understand that we have to implement the Yavadunam Taraduni Kriti Vargena Yojayat. In this sutra, we have to first find the base of the number. And again, I am repeating, the base is given in the form of the powers of 10. So when we speak of the number 12, it lies close to the base 10. In this case, the base is 10. So we have set the base first, which in this case is 10. Now, second thing that we need to do is find the deviation. So originally, the number is 12 and the base is 10. So 12 is 2 units, or we can say 2 places greater than the base 10. So here 12 minus 10 is 2, which is the deviation. 2 is the deviation in this case. So as per YTKVY, which is Yavadunam Taraduni Kriti Vargena Yojayat, 12 square equals to 12 plus 2 as per formula. And then we have the separator, then we have deviation square. This is the formula for calculating the square of any number as per YTKVY. 12 square equals to, once again I am repeating, 12 the given number plus deviation 2, as I have given here, 2 is the deviation, separator 2 square. 12 plus 2 is the left hand side part, which we have already discussed here. LHS of the separator is number plus deviation, and you can see here this is number plus deviation. Once again, LHS of the separator is number plus deviation. In this case, you can see that it is number plus deviation. Then RHS of the part, as we can see from here, 2 square, that is RHS is the square of deviation. Here students can easily see that this is the deviation square. So the number we arrive at the end is 12 plus 2 is 14, then separator, and we have 2 square, that is 4, and the square of 12 is 144. This is the way to find the square of any number by using Yavadunam Taraduni Kritya Vargena Yojayat. This is example 1. Let's go to one more example, that is example 2. If we have to find the square of 18, this is again a number which is close to the base 10. So 18 is again closer to the base 10. So deviation in this case, as per the previous slides, we can see LHS of the separator equals to number plus deviation. This is number plus deviation. And here again we see deviation is 18 minus base, which is 8. So as per YTKY, 18 square equals to given number. Here again we can see number plus LHS of the separator equals to number plus deviation. Again you can see here 18 plus 8. Then we have separator. Then we have deviation square. And deviation in this case is 8. So 8 square. It is 18 plus 8, that is 26. 8 square, that is 64. Now here students, remember one thing thoroughly, that we have after the separator, we have 2-digit number, 64. But as we see in the base, there is a single 0, because base in this case is 10. And when we see at the base, there is a single 0. That means as per YTKVY, as per Yavadunam Taraduni Kriti Vargena Yojayat formula or sutra, there should be only single digit number to the right of the separator. That is why we take this 6, we have already given here, because base equals to 10, that contains a single 0. The RHS part will contain a single digit. So as per YTKVY, this 6 should be added to this 26, because you should remember that the right hand side part of the separator should contain only 1 digit as per YTKVY that we have discussed over here. The right hand side part of the separator will contain the same number of digits as the number of zeros in the base. The excess digit, if any, will be carried over to the left hand part, and deficit digits, if any, will be filled up by putting zeros to the left of the right hand part. So as per this YTKVY, we need to take this 6 to the left hand side of the separator and add it to 26. That means this 6 is to be added to 26, which becomes 32, and then after the separator we have a single digit number, that is 4, and when we combine these numbers, that is 324, which is the square of the number 18. So everyone should understand that as per this sutra, when we find the square of any number, we should be knowing all these things, that if there is a 2-digit number to the right of the separator and the base contains only 1 0, that means we need to add the 1 digit to the left hand side of the separator and should put only 1 number to the right hand side, and in this way we can find the square of the number. Rest of things are same as we did in the previous example. You see, we have taken the given number, we have taken plus the deviation, then the separator. After the separator, we have taken on the right hand side the square of the number, and this way we can find the square of the number of 12, which is 144. Here only one thing is different, that is to the right hand side of the separator we have a 2-digit number, and 1 digit needs to be adjusted to the left, and we have added it to the 26 number, and then we are left with only 1-digit number, that is 4. And when we add 6 to 26, that is 32, then we are left with 4, and that becomes 324, which is the square of the given number. Let's take one more example. Find the square of 91. In the previous two examples, we have taken the square of 12 and the square of 18. In this case, we are taking the square of 91. Students should remember here that in both examples, previous two examples, the deviation was positive, because 18 is 10, 8 places greater than 10, or we can say 12 is 2 places greater than 10. Now in this case, if you see in this example, we have 91, which is 9 places lower than the base 100, because in this case the base is 100. 91 number lies close to the base 100. So when we have to find the square of 91, 91 is closer to the base 10 power 2, which is 100. So deviation is 91 minus 100, that is minus 9. So as per YTKVY, 91 square equals to 91 minus 9 separator minus 9 square. So 91 minus 9 is 82, and minus 9 square is 81. So base has 2 zeros. That means to the right hand side of the separator we have 2-digit number, so there is no problem. When we remove the separator, the answer is 8281, which is square of the number. Only one thing here students need to remember is that when we take the deficit number or the number lower than the base, we should not bother about anything. We have to use the same formula, only we will get a minus sign in place of plus sign. That is the only difference. In previous two examples, the deviation was greater than, or the deviation was simply positive. But here in this case, in example 3, the deviation is negative. So don't bother about that. Use the same formula. Only in place of plus sign, we can use minus sign, and the rest of the things are the same. And you can use the YTKVY sutra or the same formula to find the square of the number 91. These are 3 examples that we have used using the YTKVY sutra. In our next lectures, we will use another sutras, and we will try to solve more problems on this, and we will give some problems to the students for their practice and homework. So in this lecture, this is all about YTKVY and how this sutra can be used to find the square of any number. Thank you very much. Okay.